Imagine walking across the room to pick up your water bottle. Now imagine having to do that without moving your limbs. Motorized wheelchairs have existed now for quite some time, yet they're still bulky, expensive, and hard to use, especially if someone is quadriplegic.
To bridge this gap and to service those who suffer from quadriplegia, our group's working on developing a brain-controlled wheelchair. From this, we'll use electrical activity from the brain, which can be read on the surface of the skin, to drive a small motorized vehicle. The three functional parts that we have to our solution are a NeuroSky Mindwave Mobile, a Raspberry Pi, and a GoPi Go by Dexter Industries.
So this is the NeuroSky Mindwave mobile headset. What this has right here is a dual-purpose EEG and EMG sensor, which will be touching your forehead and collects electrical activity from your brain. This right here is a clip which connects to your ear, acting as ground. We have an onboard chip right here, which processes the signals that the chip receives, that the sensor receives. And what this can do is outputs raw EEG values from your brain, as well as a value between 1 and 100% of how concentrated you are and how relaxed you are. The EMG part of this chip also can detect when you blink.
So one of the biggest hurdles to cross in this project is integrating the NeuroSky Mindwave Mobile with the Raspberry Pi that's going to be driving the GoPi Go. In order to do this, we had to replicate what the Android and iPhone apps are doing in response to signals sent out by the Mindwave Mobile. In order to do this, we used basic Python and the Bluetooth Python library to parse what's being sent out by the Mindwave Mobile just into the air. Luckily for us, the signal's not encrypted. From various other attempts online, we were able to do a few important opcodes that are being sent out in bytes by the Mindwave Mobile, like the connect and disconnect signal and the values for attention and meditation. Sadly, we haven't been able to figure out what the blink opcode is, otherwise we'd be able to integrate that into our system. However, with attention and meditation, we've been able to figure out that when we read the byte codes, the opcodes of 04 or 05, the value that follows is the correct NeuroSky score for your current attention or meditation value. And that is how we are integrating the systems for the project.
So this right here is a GoPi Go, and it's made by Dexter Industries. And the reason why we're using a GoPi Go is because it very easily mimics a wheelchair. And you can see that it has two motors, left and right, similar to how a wheelchair would work. And another key feature of this GoPi Go is the Raspberry Pi. The Raspberry Pi is in charge of processing the data from the NeuroSky, but then again also controlling the GoPi Go itself. We have a high voltage board up here. The Raspberry Pi by itself is very low voltage, and so we have this additional board that helps us drive the motors. And the reason we really like the GoPi Go is because it has a lot of easy to use libraries. It's very easy to instantiate a GoPi Go object.
So for our live demo, Yvette's going to run our Attention Go stop test program here. So can you hit enter on terminal there? And now be as attentive as possible. She's going to do math to try and get her attention value up to get it above our threshold so this thing starts moving. All right, we're reading out values. We have a little stop and go with the instability of the values we're reading. Almost there. And here we are at a stopping point of 10 feet.